inviting me along. Thank you so much for inviting me along this evening, George. It's an absolute pleasure to be talking to you this evening about an area that's really interesting for me, which is equine sleep. And I guess this is probably about a 45-minute hour talk. I think this should run us through the main things that we're interested in, which is what sleep is, how horses sleep, why rest matters, talk about some signs of deprivation of sleep and how sleep has quite complicated relationship with welfare, and then have a look at some of the things that I'm mostly research, which is management, environment, and other things which influence sleep. I have been researching this now for around 10 to 15 years. And when I say researching, I have been lucky enough to lead projects and supervise student projects in a range of different ways, and we've looked at lots of different topics, but they've all been carried out at Hartpury, and there is no kind of medical background that I have investigated. This is all about husbandry and how we can maybe think about facilitating sleep. So we've manipulated the environment in a variety of different ways, and I guess over the last 10 years and through my PhD submission, I've picked up a knowledge of sleep, which I'm happy to share, because I think sometimes we don't pay enough attention to our own sleep. And I got into this because I had a horse on box rest when the first students approached me with a project idea. And I would go down in the morning and I would look at his stable and be like, my goodness, have you had every other single horse on the yard in your stable? What have you been up to? Because at that point in time, I wasn't thinking about what happened when I turned the lights off. I'd created a bed, I'd given him food, he had his hay, and that was that. And I would come back in the morning and just see this party stable and think, oh dear. So from that moment on, then I got into the idea of horses have a life beyond turning the light off. And since then, I've got into learning about how light influences sleep and what we understand about light. So I'll try and share some of that to you this evening. I'm happy for people to interject, but obviously I'm looking at my screen for the presentation, so I'll try and stop for questions as we go through. Happy to answer any at the end as well. And I will quickly preface this with a thanks to all the students and people that I've worked alongside who have created this research and this base of knowledge with me. Okay, so if we get into it then. I would start off just by pointing out there's a little bit of a myth around how and whether all animals sleep, and it is true that most animals adopt some kind of a rest state which is akin to sleep. So we can see here we've got fruit flies as evidence of Drosophila sleep, and there is research to show how actually sleep loss can affect worm behavior. So we move into then thinking about this wonderful creature here, the octopus, and the research here, Pop Hale et al. Suggested that this type of patterning that you see with movement around the skin is indicative of rapid eye movement sleep. And you would see these kinds of things during a wakeful state as well. And rapid eye movement sleep is very similar to wakefulness, but obviously is a period of unconsciousness that facilitates rest and recuperation, which we'll talk about in a little bit too. So I just wanted to start off with highlighting that lots and lots of animals sleep or rest. And the most fascinating one probably, even though that octopus was pretty cool, is this one of whales sleeping in the ocean. So I had no idea that this is how whales sleep, and now I just want to share it with everybody. It's brilliant. Okay, so what is sleep? It's a dynamic process, and what I mean by dynamic is that it represents a continuous state that is influenced by complex physiological interactions, so things that are happening inside the body, maintained through continuous adjustments, and that is in response to fluctuating environmental variables. So much as we are unconscious, there is a way in which we sleep which enables us to constantly check and be aware. And that dynamic process is controlled both by circadian rhythm and by homeostatic processes. So that means that it's influenced by the light-dark cycle, and it means that our body is constantly seeking to provide us with the correct levels of sleep. So where we have maybe a period of sleep deprivation, we get increasingly tired. That is a homeostatic rebound effect where we're looking to try and encourage the body to rest and repair. And the second thing I've put in there is what is sleep. It's comprised of two different states. So we have a state of non-rapid eye movement sleep and a state of rapid eye movement sleep. Non-rapid eye movement sleep, sometimes called slow wave sleep, when we look at brainwave activity, and rapid eye movement sleep is sometimes referred to as the dream state, and one of the characteristics that you would see is rapid eye movement at that time. And the brainwave activity of those two states is very different. Non-rapid eye movements can be broken down into three different stages, but rapid eye movement sleep is just one occurrence. And I'll show you how it occurs quickly for humans. So this diagram here is a hypnogram, and it helps us to look at how sleep occurs across the night. So night 0 here at the top. At the top of the graph, 0 hours is when the person is still awake, and then falls slowly into stage 1 of non-rapid eye movement sleep, and then transitions through into stage 3, which is the deepest level of sleep. And it's represented nicely on this hypnogram because it goes right down. And this is called the descending loop of sleep. So if you try and wake someone up as they are falling asleep through stages 1, 2, 3 of non-rapid eye movement sleep, it actually encourages them to fall asleep quicker. Then we have the ascending loop where we go back through stage 2, possibly into stage 1, but then up into rapid eye movement sleep. If you wake someone up during this ascending part of the loop, the cycle, then they're more likely to stay awake because the pressure for sleep has reduced as they are starting to cycle towards rapid eye movement sleep. And as I said before, rapid eye movement sleep is very similar in its brainwave activity profile to actual wakefulness. And it's suggested that this phase of sleep is a way in which we can kind of test our surroundings to work out whether something is or isn't happening that would either encourage us to wake up or encourage us to fall back asleep again through another cycle of sleep. So you can see with rapid eye movement sleep being the end part, there are probably 1, 2, 3, 4, 5 cycles of sleep that occur throughout the night. And as we get into the early hours of the morning, so from hour 5 through to hour 8, then we can see that people generally tend to have micro kind of wakefulness periods, and that is in preparation to wake up fully. Now, it's only really in the last 100 years or so that we've kind of evolved to have this kind of sleep cycle. So we've consolidated all our sleep into the nighttime, because that's when nothing really very much happens in society, so that we can rest and recuperate ready for the next day of whatever it is we're doing, which is likely work or at least activity. And I say that because some people would wake up at this 5-hour process, this 5-hour part of the night. And in the Victorian ages, in fact, that was called you would have a second sleep. So you would get up and do something at that point and then go back to sleep afterwards. So there is no kind of normal sleep in a way. I just want to encourage everyone to think about their own personal sleep and how they can facilitate good sleep. But anyway, so we've talked about how this is a human profile of sleep, and we can talk about that increasing pressure and the decreasing cycle, and that's supported by the start of the dark cycle. So at hour 0, it's very likely that it's dark, and dark suppresses the production of serotonin, and serotonin promotes wakefulness and positive mood. So when it becomes dark, the brain kind of switches off the production of serotonin and in fact starts to convert serotonin into melatonin, which is what induces sleepiness during the dark hours. So it's good to know that our brain is chemically controlled and is largely then cued by the light-dark cycle. And it's no different for horses, but we will talk about the differences slightly in a minute, because obviously they don't do all of their sleep at night. They are not monophasic sleepers, so they will be polyphasic. They will sleep throughout the day as much as they will then sleep normally between 10 and 6 a.m. 10 p.m. and 6 a.m. you'd see most of nighttime sleep for horses, but they will sleep throughout the day. And that's because they're largely opportunistic. As a prey animal, that's how they've evolved. So resting when you can get it is a great idea, because you don't know if you'll have to be moving at nighttime or not. And that can be seasonally affected as well. So we see that perhaps in hotter places, horses would sleep more during the day, because what else are you going to do? There's a lot of stuff that you can't do because it's just too hot. And then at nighttime, you can start to engage in more behavior because it's cooler. So there's seasonal thing. We've talked about prey instincts having an influence on horse sleep as well. We can say that for horses, on average, they spend around 4 hours in 24 hours in sleep, and 13% of that is REM sleep. And humans sleep on average for around 8 hours, or are encouraged to sleep on average for 8 hours in 24 hours, which is around 17% of that is REM sleep. So much as horses appear to sleep cumulatively less than us in 24 hours, that amount of sleep is still really important for them. We still need to consider how we are definitely facilitating that for them. And in terms of that 8-hour average for humans, definitely try and reach that. But it very much depends on age. And there are recent studies telling us how, in fact, there are super sleepers genetically. So there are some genes out there, you can get hold of them. There are people out there with the genes who can operate on a minimum of 4 to 5 hours of sleep per night, which blows my mind. I can't imagine anything worse. Now is a good time to talk about the importance of rapid eye movement sleep and the difference between that and non-rapid eye movement sleep. So REM is where we'll talk about the importance of it shortly, but we'll talk about memory consolidation occurring in rapid eye movement sleep. And one of the key features of rapid eye movement sleep is that there is kind of a reduction in muscle tone. So voluntary muscle tone is completely, much of it is lost during rapid eye movement sleep, which is why we all have to lay down, particularly to achieve that state of sleep. And it's no different for the horse. So they have the passive stay apparatus in the hind limbs, which enables them to kind of lock in and stand and achieve certain stages of non-rapid eye movement sleep. But to achieve rapid eye movement sleep optimally, then we are trying to encourage them to adopt a recumbent position. Now, when we started this is an open access paper. This is a consolidation of all of the information I knew in 2022 with Dr. Sebastian McBride from Hartpury University, where we put together a review of sleep. And we talked about how in these different stages of sleep or states of sleep, actually the behavioral markers, there's not an awful lot that we can say distinguishes between each of these really, really, really well. But we had a really good go suggesting when horses are or aren't asleep based on their behavior. And that's how we carry out our research. So currently we are using an ethogram, so a catalogue of different behaviors to make inferences about when sleep is occurring based on a lot of the seminal research using electroencephalography or brainwave activity. So we'll talk about the different stages in just a little bit, but just at the top here now, we have a hypnogram of horse sleep. This came from a German group from the University of Munich. So Christine Fuchs, Caroline Vore, and they used electroencephalography, looked at brainwave activity on a number of different horses. We borrowed some of that to show here because the hypnogram is a lot busier in this. And I'm not saying that all horses look like this. That's not every horse's profile. But this one particularly we were interested in because it started to show that horses were there was lots and lots of wakefulness in amongst the sleep. So rather than falling into stage 1 and then 3 and then back up to REM, this horse has maybe been awake, fallen into stage 3 and woken up again, then gone into stage 3, woken up, stage 1, woken up, stage 1, woken up. So anyway, we started to say that the way that we were measuring behavior by looking at the accumulation of behavior duration, how long they were lying down for, how long they're in this particular posture for, etc., wasn't accounting for perhaps this amount of wakefulness that was occurring within there. So if this horse had been standing rest and we had started the duration from the first point of wakefulness through to the final big block of wakefulness, that would have been maybe 30 odd minutes. And in actual fact, in here, there's probably 10 or so minutes of wakefulness that the horse is engaged in through those kind of micro arousals. And we started to band around the idea of how sleep quality, as much as sleep quantity, should also be important. And we came up with some equations, and we're trying to validate those with partners now to be able to look at quality as much as quantity for horses as well. And that's important because we all know what we feel like when we've had a really subjectively rubbish night's sleep. It is awful, isn't it? Whereas our horses can't tell us that. So we can have a look at whether they have laid down, but if they've laid down for 5 minutes or if they've laid down for half an hour but woken up multiple times during that period of time, how does that influence their daytime feeling? So we're fascinated in that. That will be the next step. So let's have a look at some videos then. This, as we start to talk about behavior, this horse, hopefully this video is going to play. Oh, it's quite slow. This horse is in sternal recumbency in his stable. And we think at this point you can see that the muzzle will be placed on the floor. And when the muzzle is placed on the floor, we start to suggest that that could be indicative of rapid eye movement sleep, because the muzzle placement and some tonality in the neck allows the horse to relax the rest of its body through REM sleep. So if we see a horse in sternal recumbency, as long as its head isn't up, then we suggest that perhaps that horse is asleep, and we can start to think about ear movement and eye movement when we can see that better as well. And I'll just point out that this video is actually ticking through quite quickly on 1.5, I think, 1.5 times. So it looks a little bit more than it is. But in a minute, you might see some jerky movements, which are linked to the fact that the horse is kind of pivoting around that central point on its muzzle in a state of sleep. At this point, the ears are kind of placed backwards. There's a little bit of movement there. Definitely having a lovely time there. So that's sternal recumbency. And in that period of behavior, we would start to talk about that perhaps as rapid eye movement sleep. This video was taken from a study where we used red light, which I'll talk about shortly. Horses don't perceive red light in the same way as they do for white light, but I don't want to give anything away before we talk about that. So horse in sternal recumbency. And then we have this horse in lateral recumbency. This horse had a preference for lying in this kind of posture, but for some reason at this time of night, he was squished his head up against the side. I don't know why. And you can start to see here, we've got rapid eye movement. And with that rapid eye movement, you've got some jerky movements. You've got a little bit of ear movement there. But this would be an example of our horse in lateral recumbency. And most of the time when a horse adopts this posture, it is for the purposes of achieving this sleep state. And there are lots of reasons why horses wouldn't achieve this particular posture. We talk about horses that maybe feel vulnerable in their stable. So this is a hugely vulnerable position where the animal can be easily predated upon in terms of instinctive feeling and behavior. We might also talk about how difficult it is for the horse to achieve any state of recumbency. In the dairy world, they have a knee drop test, which talks about if you drop to your knees in your horse's stable, A, does it hurt? And B, after so many, in a cow barn, if you drop to your knees in a cow barn, A, does it hurt? B, does it make your knees wet after a certain period of time? Which is something I think we could all start to borrow on, because that's 500 odd of a horse dropping onto its limbs, and then it has to heft itself up from that position as well. So if there is any pain associated, if there is any pain present, then that might be a limiting factor for a horse adopting this particular posture. But hopefully a good insight into a horse's stable at night to be able to see what we're seeing when we do our behavioural analysis of videos. So from an evolutionary perspective, when we start to ask the question, is sleep essential? Because nearly all animals, pretty much all animals, achieve some rest state or some sleep state, we can talk about this as an adaptive role. So it has to have something about it that increases the overall fitness of the organism. And where we talk about the fact that this is such a threatening posture, this is a situation where the animal is massively vulnerable to predation and it represents a significant danger to survival, then it has to be important for the animal to achieve it in the first place. So yes, we say sleep is hugely essential. And we can think about the importance of sleep coming back to the human literature. Bupa, good old Bupa, suggests that there are 8 benefits from good sleep. So for us, for humans, it improves concentration and attention. It enables us to learn better through consolidation of memory. There are positive links with maintaining healthy weight. It keeps the heart healthy through rest and recovery. It aids the immune system through rest and repair. There's emotional and mental health benefits, and it reduces stress levels because when you're asleep, you have triggered the parasympathetic nervous system, so you are in a decreased state of arousal. So all of these things then help you maintain good relationships. It's been proposed that largely sleep is for the brain, so it can encode information, consolidate information, and retrieve information better the next day. So the main thing that we think about for horses probably is memory consolidation. So during sleep, the brain state is optimizing this memory consolidation because during wakefulness, the brain cannot encode, is encoding memories, it's taking in information and it is being quite reactive. But during sleep then is the opportunity for it to be able to categorize and think about what that actually means, and then either take it to long-term memory or keep it in short-term memory. Either way, it's suggested that a state of sleep you wouldn't be able to operate. And there's some evidence from a human study where people were deprived of sleep, and slowly during that period of time, over weeks and months, they started to hallucinate. And it was suggested that those hallucinations were in fact the brain trying to achieve a state of REM, so trying to be awake and be asleep at the same time, which I think is quite interesting. Nothing that we have observed in horses, but maybe that's because we haven't looked for it yet. And this is just the kinds of stages, if you like. So we can talk about a procedural activity, which involves performing a procedure or a sequence of activities to achieve a goal. And it can either be a physical one, like performing a tennis serve, or it can be learning and processing in sequences of rules in language, for example. So essentially, it's linked to the formation of habits, not related to conscious recall. It's more about spatiotemporal memory. So thinking about space and time. So rather than trying to learn something sight-wise, you learn something quite subconscious in a way, I guess. So it's suggested that forgetting can be reduced when sleep has occurred. So if you want to learn something, do it in the evening before you go to sleep, because the evidence is that once you've learned something in the evening and then you sleep on it, there is less forgetting 24 hours later, especially less forgetting than if you were to try and learn something and not learn it in the morning and then not sleep on it. And, you know, the work that we've done with horses trying to look at sleep and memory, because they're polyphasic, opportunistic sleepers, it's quite difficult to try and put that into a research study context. But I'm sure we'll find a way sometime, because the next thing has to be, so how does this translate into how our horses operate when we ask them to do the things that we want them to do? And that, I guess, comes through to the question that's been asked very recently about what a good life is for a horse. And according to Professor Natalie Warren, you can see that sleep kind of is the medium point of negative and positive, because the animal is unconscious at this point, but it is significant. It's something that has to happen for the animal to have a good life. So I don't think I need to hammer home that message anymore, but hopefully that has enabled you to have a think about what sleep is beyond how we experience it, thinking about how the horse experiences it, and what we know to date. Okay, so we can move into thinking about signs of compromised sleep. Probably the biggest or highest profile sign is spontaneous collapse. And I know that Christine Fuchs and a group in Munich have been looking into this a lot. In fact, there's Christine runs a clinic in Germany if you're interested in sending some footage over. She does a lot of behavioural work as well as veterinary work, being a practicing vet herself. So I will talk very lightly about this. Spontaneous collapse, where horses are falling over at night or during the day, in fact, is problematic because it's a risk of injury in a number of different ways. So you hear about horses with abrasions on their hocks or on their knees or around their fetlocks. You also hear about strains and pulls and things where the horse is fallen in a really weird position. And the idea is that this spontaneous collapse, as we understand it, likely is linked to rapid eye movement deprivation, sleep deprivation. Because what we tend to see is that these wibbly wobbly horses are the ones that aren't lying down. So they're not achieving a recumbent posture consistently, night to night to night to night, over a long period of time, no recumbency. So it's almost like this is adaptive for them in a way. So Christine suggests that the work that they've done shows that rapid eye movement sleep is occurring in kind of microminutes or microseconds. And I'll show you a video now to try and explain that. So this is a horse in its stable. This is what we would suggest as the horse is falling asleep here. So the pole is moved to be next to the wither. But in this situation, the head is dropped further to the floor. The horse starts to stagger. The muzzle drops to the floor also. And in this second, as the horse's head is this low and it's balanced itself, it's suggested that actually it's achieving a state of rapid eye movement sleep. Now, this horse would cycle like this multiple times in the night. And you would see also that he's propped himself up against the wall. So quite clever in the way that he is managing his spontaneous collapse episode to achieve rapid eye movement sleep, because he just did not want to lie down. And so I know that there's a whole host of research that needs to happen, because not all horses do it like this. Some horses fall forwards, some horses fall sideways. Sometimes it's not linked to rapid eye movement sleep at all. And so I have to be very careful about how and what I talk about here. But what, as I understand from this particular example, we would talk about as rapid eye movement sleep deprivation and some form of close to spontaneous collapse. So other signs of compromised sleep that you may or may not have experienced. So if you are riding a horse, or if someone is riding the horse, you know the horse particularly well, normally you would ride at a certain intensity for a certain amount of time, and you're seeing that the horse is fatiguing ever so slightly earlier than you would expect it to. So it's starting to run through or refuse to do something. That can be a sign of early fatigue. We can talk about that as less willing to go forwards. And sometimes perhaps you might see more stumbling during work, where the animal's having to work ever so slightly harder in terms of concentration or attention. And working through that homeostatic rebound for the need for sleep, especially when you think about the time of day of the training potentially as well. Maybe another sign of compromised sleep might be that the horse has forgotten the training from the previous day. Maybe it hasn't had the opportunity to consolidate that procedural learning. And so you're asking it to do something that it hasn't particularly consolidated enough to be able to do it again the next day. So that might also be another sign of compromised sleep. And perhaps you might see mood or appetite changes as well. You kind of skip through that Bupa recommendation around good sleep, maintaining a healthy weight. But the idea is that if you have a poor night's sleep, certainly I'm talking from experience, I wake up in the morning and I just want A, caffeine and B, sugar. And that kind of continues. You're looking for calories through the day to kind of keep your energy levels up, because your body is desperately trying to make you sleep without homeostatic pressure. So that's where we talk about good sleep and good sleep routine to kind of maintain a healthy weight. And it might be that you see appetite changes in your horse. And those mood changes might be linked to the fact that they are tired, or it might be linked to kind of that appetite drive or changes in hormones as a result. So always worth keeping an eye out for these types of things. They are, of course, largely anecdotal, but I'm hoping that as we start to talk about these, we see more researchers getting interested in this and providing some quantitative data in the future. Okay, so how might sleep be compromised then? So we talked about the horse that maybe didn't want to achieve a recumbent posture, and we talked about perhaps a vulnerability, so they don't feel comfortable or safe in the environment to lie down. But we can also talk about potential pain, and that can come through age. So older horses tend to lie down less frequently, but for longer periods of time, because then they can kind of consolidate that sleep without having to keep getting up and down and up and down. And that might be linked to effort, it might be linked to pain, it might be linked to injury. Injured horses may be less willing to lie down also. Um, so that's all about recumbency. But other factors influencing sleep generally, we might talk about younger horses engaging in much more sleep than older horses, and older horses achieving different types of sleep at different times of the day. We might talk about how exercise, light, and temperature are huge cues in terms of encouraging sleep. So, light, we talked about the light dark cycle, but temperature through core body temperature changes as a cue for sleep. So, as you fall asleep, you release energy. So, you essentially cool down, and that cooling enables you to, or is linked into falling asleep. And it suggested that exercise can also be a cue for sleep, but for horses, certainly need to look into that in a little bit more objectively. I think at this moment in time, we've made a start, but lots more to do there. There is a social element to sleep. When everyone else goes to sleep, that's when you think, well, maybe I should go to sleep as well. And that's generally the same in a barn and in a field even. We can talk about the need for sentinel animals, so where they would stand watch to make sure that other animals were getting sleep and then swap round. You often see that in a field. If all the horses are lying down at the same time, no watch out horse, and that is a really feeling safe, comfortable group of horses in a field for sure. And when you think about that and how it translates into a barn where horses can't see each other or very limited in terms of their visual horizon, then that can affect the social cue behind sleep. The microbiome is receiving increasing attention at the moment. I don't know enough about it, but I know that we talk about the gut-brain axis and knowing how the brain is very much involved in sleep, and how the gut and the microorganisms that live in there, healthy or not, might influence that sleeping component. There's been some provisional stuff in that area, but massively interesting future area for research. And then the available location. So for me, as I start to look at horses in stables, I start to think about the surface area that's available to them to lie down comfortably. So the horse that we saw in lateral recumbency with his head squished against the side, if he'd shoved down a little bit, then he would have been able to stretch out, but he lay where he lay, and so he used the space that he had. And when you think about the bed that was available across that floor in terms of comfort, thinking about maybe insulating against rubber or under other floor surfaces, we really advocate for bigger beds, but we'll talk about that in a minute anyway, I'm sure. And just to highlight that there are this relationship between kind of sleep and stress and welfare is hugely interrelated. So environmental factors and physiological and physical stresses obviously can reduce sleep, but at the same time, those factors and stresses can cause increased stress, and that increased stress by itself can reduce sleep. So you never know really what it is that is causing the animal to experience poor sleep in the first place. But there are some things that we can start to think about environmentally to encourage sleep, or at least rule that area out. And it's really a cool time to be talking about sleep, it feels like, because we see the changes that came in a year ago from the FEI regulations around the level of lighting in FEI stable areas, and also K, for me, the most important one, the closure of the FEI stable for at least 6 consecutive hours overnight with minimal lighting and noise to allow the horses to rest adequately. I mean, that's gold dust for me. I was so excited. And you see that kind of moving over into the USCF as well here, promoting sleep-friendly stabling. So cool. So what is sleep-friendly stabling? Well, it's a good question. In humans, perhaps we start to talk about it as sleep hygiene. So we are looking for healthy habits. We talked about diet and exercise and routine times for trying to get to sleep, and creating an environment that promotes sleep. So that for us is kind of good sleep hygiene. And we can talk about that in terms of schedule, routine, comfortable, cool environment, avoiding stimulants, including foods that disrupt sleep, coming off screens fast, dimming the lights and getting regular exercise. All of these things are suggested to encourage us to sleep better. So how can we, should we, can we translate this across to horses? Because hygiene is a relatively new term. This is really relatively new in the last 5 years for humans. And it's only come in because it's been recognized how counterproductive sleep is in terms of the economics of the country or the world, really. So by encouraging better sleep, then you are increasing productivity. I guess that's all we're really ever looking to do. So in terms of comfort here now, in a pilot study, we created different bedding depths within stabled horse environments. We went from 5 centimeters to 10 centimeters, and we found that the behavioral profile in terms of recumbent postures improved on deeper beds. So we repeated this in a collaborative study with Aberystwyth University students, and we looked at 5 centimeter beds as being the treatment beds and 15 centimeter beds as being the control beds. That's what they were normally bedded on for straw. We ran this as alongside differences in light. So there was a treatment of light on overnight and a treatment of light off overnight. And each treatment lasted for 6 days with a washout day in between. And you can see in the table below how we staggered those different treatments over the 35 days of this study. And we conducted 24-hour observations over those 6 days using continuous observations of the horse in its stable to be able to create durations of behavioral states, to be able to compare these between these different treatment environments. And one of the key things that we found then were really that lights overnight significantly reduced sternal recumbency. So statistically speaking, that was a significant difference. And lights overnight significantly then when they were on, lights overnight on, significantly increased standing sleep. So there's almost a trade-off. And then reduced bedding depth also reduced recumbency. And we saw an increase in standing sleep as a result of that too. So by manipulating various factors within the environment, we started to see that it did have a knock-on effect for these sleep-related behaviors. And the suboptimal conditions were resulting in significantly reduced times in recumbent states, which we said were quite important for sleep, or inferred that sleep was happening. Just checking the time. We're doing okay. The next one in terms of comfort then, and core body temperature, really interesting to think about that. Core body temperature is typically measured using rectal temperatures, and we weren't really keen on going in and taking rectal temperatures of horses across a 24-hour period because that would affect their sleep for sure. So we wanted to look at a novel measure to see whether a less invasive method could start to tell us about the microclimate underneath the rug, essentially, and whether those temperatures had any kind of relationship with sleep-related behavior. So on the left then, in 1A, you can see the buttons, and 1B is a patch where we sewed the buttons inside the rug. And that kind of positioning was just on the indentation of the wither to make sure that it didn't really influence the horse in terms of when it was laid down to be uncomfortable, and would also measure that microclimate. So we measured overnight under rug temperatures for each night, and we looked at them individually for each horse, and we looked at differences in those under rug temperatures against behavioral states in the table on the right hand side there. So lateral recumbency, sternal recumbency, and standing rest. Now then, let's see, can you guess the mean under rug temperature, the minimum or the maximum? Let me see if I can try and, anyone can stick it in the chat. I can see that the chat, if anyone wants to guess the mean under-rug temperature minimum, so this was in November, for horses that were wearing light to medium rugs that were trace clipped, I think is the terminology there. And because I'm conscious that everyone is conscious of contributing, I will tell you that the minimum temperature was 14 degrees centigrade. So the under rug temperature minimum was 14 and the maximum we recorded was 34 degrees centigrade with an average of 22.9. And I think that it surprised everybody because didn't mean that the horses were consistently at 14 degrees every night that we observed them. In fact, there was large individual fluctuations. So it shows perhaps how important something that would give us an objective measure of the under rug temperature could be in the future. And the mean rug temperatures were different across all horses across all nights, but there were no significant relationships determined between the under rug temperature and the total duration of behavioural states. There were some patterns that were described, but because it was such a small sample, we can't really infer anything from it. So we were just happy that the eye buttons could help us perhaps investigate this in the future. And in fact, there's a master's student, Olivia, who will be looking at this data now for her dissertation, and hopefully I'll be able to report something back in the future. So lighting, we started to talk about how light is a massive cue. And in this study, we were looking at circadian rhythms, spontaneous blink rate, and sleep behavior in stabled horses. And you can see A is white light, B is red light, and C is normal fluorescent lights. So we were comparing A and B against C. A, white light, was on between 7 a.m. and 7 p.m. and B, red light, was on between 7 p.m. and 7 a.m. And there was a gradual change between this, and it was an automated system. And we had cameras in the stables, continuous 24-hour sampling of horses. We were taking gene. Oh, hang on. I think we've got some more slides to explain this. Hang on a second. So this was our horses, and this was our data collection schedule. So they would be in a 4-week experimental situation under these lights. And in the 4th week, we would do this. So Monday, we would look at spontaneous blink rate. Tuesday was video recording through until Friday. And then on Thursday, we would start the hair follicle collections, because the hair follicles are what contains the clock genes, which tell us about circadian rhythmicity. And we swapped them over. So there was group A that did white and red versus group B that did fluorescent. And after 4 weeks, then we swapped them so that group A looked at the other, was in the other treatment experiment, and the group B was in the other. So then we compared them all together. And this was the ethogram we used. It's a little bit more detailed than the last one. And the key findings were there was no difference in spontaneous blink rate under the different lighting conditions. We suggested that management of horses kept them in a under-aroused state, which was a good indication for the study. There were no differences observed in the mean duration of each behavior between treatment and control. So animals were displaying nocturnal behavioral profiles that were not significantly different, whether they were under fluorescent or the red-white system. We saw significant differences in behaviors over day versus night, which we expected. And there was an overall effect of time for clock genes. So you could see across the 24-hour period how the gene expression changed, but there was no effect of treatment or time by treatment either. And that helped us to suggest that dim red light at night doesn't appear to impact on normal sleep patterns in horses compared to natural dark conditions, and in fact maintained a strong circadian rhythmicity. So red light at light is a good substitute for dark light, for no light, sorry. And where we start to talk about late night checks, perhaps using red light would be beneficial, because there's other research out there by Collery et al. That suggests that actually interrupting horses by turning lights on can desynchronize circadian rhythmicity, which can have effects. physiologically then as a result. Other things that we started to think about is that routine. So thinking about quiet times on the yard during the daytime to facilitate rest, so that animals know that they aren't going to be overstimulated all day long. And if they need to rest, then there will be a period of time during the day where they actually can. We did this by looking at soundscape. We measured, these are decibels, so how loud different locations were at different times during the day, during what our yard talked about as busy and quiet periods. And we did see some significant differences. 0 decibels was never observed, so it was never silent. And what is silent these days anyway? They generally stayed within a range of 41 to 68 decibels, so like a normal office conversational kind of loudness throughout the day. And we started to suggest that because of the differences in locations, some were louder than others. Maybe we need to think about where our horses are being placed, because if you're an aroused horse, like you're a sensitive horse and you're in a loud situation, how does that play into how you adapt to that environment? Do you ever get to rest even when it's quiet? Are you always expecting something to happen, etc.? So some interesting results came out of that. And then thinking about noise and sound, we started to talk about auditory enrichment at night. And this came from a study conducted many years ago, the different types of music played to animals and how much rest behavior was shown as a result. Jazz behavior, jazz and rock music were the ones that caused the most aroused behavior, and classical music resulted in the most rest behavior. So we used classical music in this preliminary study overnight to see if that would encourage more biologically significant behaviors. And we did see that, in fact, lateral recumbency was affected. So we saw maybe more sleep in phase B, which was when the music was being played, with a rebound in phase A2 when music had stopped being played again. We also saw maybe changes in sternal recumbency, and standing sleep reduced whilst music was playing, but then was increased after when music wasn't playing. So we started to suggest that actually nighttime enrichment, because of being a prey animal and having such a keen sense of hearing, anything in an environment that you're unsure of, you're going to listen to. And in fact, when it is quite quiet at night and you hear a noise, that's almost worse than having constant noise all of the time, because that is more stimulating. And so by creating a blanket of noise in the background, rather than coming out of nowhere and then wondering if it's going to come back again, you've got a baseline of noise which kind of dampens the stimulating effect of novel auditory stimuli. But perhaps classical music, Beethoven, isn't really horses' bag. So we came across different coloured noises, and I'm not sure if you've ever heard of different coloured noise. I am assuming most people have heard of white noise, which is kind of that high pitch, kind of hissy, kind of crackly kind of noise that is some people like. But there are other frequencies of noise. And in fact, from white noise, you can go down through kind of green, red, brown, pink. All of those are lower frequency kinds of versions of white noise, essentially. And we suggested this would probably be more useful than Beethoven for horses, where you're just trying to create blanket noise consistently. These lovely students conducted a study, but as dissertation students, we struggled to get the data analysed. So we're looking for others to help us with that data analysis to report that back. But anecdotally, everyone enjoyed the pink noise being played overnight. It's quite nice. And I can recommend it to anybody who is interested in helping them get off to sleep. Also good for studying, apparently. Anyway, then we get into this concept of exercise. It is recognized as a cue for circadian rhythms, and it influences sleep architecture in terms of what happens, amount of non-REM versus REM, when it occurs, when it doesn't occur. So we were really interested to start a provisional study in this area, thinking about how much increased exercise might affect behavioral profiles at night. And in this situation, we had horses in their normal routine of 2 hours of medium low intensity work versus phase B, which was 4 hours outside the stable, which wasn't ridden work, but it was on the ground handling with humans. So maybe more intense in that sense, versus then back to 2 hours of medium low ridden work again. And with that increase in physical activity, so that in that B phase, we did start to see that horses were engaging in longer and more frequent sleep bouts at night, indicating that perhaps there is an adaptive response to exercise that is required to meet recovery needs. And the longer sleep durations persisted into that second A phase, suggesting that perhaps recovery extends beyond the immediate training sessions. So we were really pleased with the provisional results that we got from this study, which we hope to publish, which will be open access shortly. And we hope to be able to continue this area of research, particularly thinking about maybe how sleep does or doesn't factor into fitness as much as how exercise then factors into how well animals sleep. And we started maybe a little bit of thinking about how sleep affects performance at the other end of the scale with a small study where we measured horses' sleep for 2 consecutive nights and then asked them to jump around a course of jumps twice. And they accrued faults, which added on to their time, which gave them a score at the end. So 1 was the best score and 10 was the worst score. And you can see perhaps that with less sleep, you get a higher score, and with more sleep, you get a better score. So closer to 1, 2, 3 achieved with better sleep. So we started to make some suggestions, that sleep can be affected in a number of different ways. And in actual fact, that comes around to how the animal is operating on a day-by-day basis, something we should maybe consider a little bit more going forwards. And we made some recommendations. So one of the key ones that we have made is to increase your bed depth to at least 5 centimeters or more, regardless of whether it's on rubber mat or not. So rubber mat isn't a replacement for bedding unless it's hospital grade rubber matting, which I would sleep on because it's so comfortable. There's a whole host of research to be done into kind of the conduction of heat as an animal is lying on this substrate versus the floor in different ambient temperatures to work out whether the horse is trying to save energy or stay warm, and how that is leached into the environment or not. But from a comfort perspective and from the results that we found from our studies, a deeper bed does encourage more recumbency, which we would like to think is linked to better sleep and therefore better well-being overall. We also advocate for turning the lights off overnight and having a distinct light and dark cycle. So if the lights have been turned off, then you do not turn them back on again. And if you can, to operate under red light, even with head torches, as you kind of adjust. It's quite a good light to be able to operate under, and you can see quite a bit with, anyway. You might also consider where light pollution is affecting your horse. So for example, there was a yard that I was working alongside, and as I was there one night, the lights were all off in the barn, and all of a sudden, one of the competitors that was over in the other arena came and turned the light on in that barn. I said, "Why did you do that?" She said, "So I could get some water for my horse. I just need to turn the tap on." I was like, "Oh no, don't turn the light on though. I'm sure you can do it with the outside lights here." But even the outside lights, to help the competitors who are unloading and loading their horses ready to go to the arena, you wonder how that influences the horses that were in that particular barn at that time. So just a really interesting point around your light dark cycle management and whether there is or isn't any concerns about light pollution. We're also interested in thinking about under rug temperatures, as everybody is these days, just another angle to think about the importance of that, I guess. And then considering the effects of exercise on your horse. So when you're exercising it, what kind of rest period you're giving it, what recovery kind of time you're giving it in terms of the intensity of that exercise. And also then how nocturnal soundscapes might be influencing your horse's feeling of comfort and safety in terms of being able to sleep in its environment without being overstimulated by those novel auditory stimuli. So that gives you a real rip ride run through the research that we have been conducting at Hartpury over the last 10 to 15 years now, I guess. On the right-hand side is our attempt at a poster to encourage our FE students to standardize the bedding that we expect to see in a stable to be able to facilitate our horses that there for them for practicals and riding research. We understand the pressures of the cost of living currently, and we are currently undertaking a second study to look at different types of bedding to be able to make some suggestions perhaps around practical bedding measurements or bedding types that would encourage you to follow this kind of protocol. But other areas that we're really interested in are sleep quality and latency to sleep as other measures of sleep. Oh my goodness, we must engage with AI on this. So if I tell you that the study that we did with Aberystwyth generated over 5,000 hours of footage, and each hour takes around 10 to 20 minutes to view, that is a labor-intensive period for this type of research. And if we were able to automate it, then all the better. And we're working with a company called Vet Vision currently, who has PhD students that are investigating how the system or the deep learning machine would be able to correctly identify, I guess, at least rest behavior. There's nothing under the heading of avoid ingesting or other stimulants before bed. So I wonder how we are considering that in our horses' sleep profile, linked through to the microbiome. We're particularly interested in how horses habituate to staying away for competition. So that novel environment as a prey species, how do you overcome the unfamiliarity of a stable? How do horses do it to be able to achieve good sleep whilst they're at competition? And much as we've done some really provisional stuff in the field, we still don't know how horses are or aren't sleeping outside. All horses are individual. I hear anecdotal stories of horses that won't sleep in the field. So summertime are wobbly, will come in the winter, and that's where they sleep, not wobbly. So all horses are individual, and the recommendations that we're making obviously will be useful for the majority of horses, but all individuals are different. And that comes down to the social stabling. So this is an increasing area of interest for our industry, massively so, because horses are social. In and around kind of how do you mix and match your pairs to make sure that they get on? How do we know that they are still achieving a good amount of sleep, and actually having a horse next door, does that encourage better sleep or not? Is a question that needs to be answered. And I think my colleague Lorna Cameron will be publishing soon in that area, I think. So I didn't stop for questions. I just got on with it. I hope you don't mind. But in conclusion, we can manipulate the environment in several ways to help our horses achieve good quality sleep. We've talked specifically about lighting, bedding, temperatures, noise and routine, but there is tons of research that we carried out in this particular area, and particularly from an individual horse perspective. So really searching for funding at the moment to facilitate that. But otherwise, hopefully that's been of interest as an introduction to the importance of sleep. And I am happy to answer any and all questions that anyone might have. I did check that there are none in the chat yet.